Hey guys, how you doing? It's Jalajora here again, back with another video from Biogem at GCC Chem, and today we're going to be doing section C3.3, which is all about ionic bonding, which is called ionic bonding. And this is the book I'm using. It's the AQA GCSE Chemistry Caboodle revision guide. And I made a video yesterday which is about mostly about ionic bonding. There was also some covalent bonding there as well, but it was mostly based around ionic bonding and kind of how atoms form ions. That was basically what the kind of yesterday's video was about. But today I'm going to go purely on ionic bonding. So if you didn't understand something from ionic bonding, hopefully in the last lesson, hopefully in this lesson it will all be you'd fully understand it and everything will be cleared up for you. No, that's what I aim to do. And by the way, I couldn't upload the I couldn't put the link to my website for C3.2, so I'll be doing both C3.2 and C3.3. So I'll be putting the links to both those videos after obviously I uploaded this one on my YouTube channel. I'll be basically putting links to both of the videos, C3.2 and C3.3, on my website by today hopefully. So sorry for not being able to do that yesterday. And so today we're doing C3.3 ionic bonding. So let's begin. It's a really short section today. So ionic compounds are formed when metals react with non-metals. So that's obviously we know that from the last video as well. Yesterday we talked about ionic bonding ionic compounds forming from reactions between metals and non-metals. Basically so when metals react with non-metals, you form ionic compounds. Now, the oppositely charged ions formed are held together by strong forces of attraction, which act in all directions. So these strong forces of attraction basically act in all directions, and this is called ionic bonding, and a giant structure is formed. Now, this can also be called a giant lattice. So we know that basically when these there's oppositely charged ions, they kind of attract each other, and this kind of they're held together by a strong force of attraction which are in all directions, and basically from this a giant structure forms from the ionic bonding process, where the metal and non-metal where the metal atoms and non-metal atoms come together. Basically the ions basically come together and they form compounds, basically those ions. So from those ions compounds are formed, and you call it a giant structure and it can also be called a giant lattice. So that's what's formed. Or you can to be more specific you should say giant ionic structure, and also known as giant ionic lattice. So add the word ionic there. By the way, I don't know if I mentioned this, but if you're following the student book, which is obviously the big textbook, it's pages 41 it's pages 40 to 41 that you should be that you should go to basically to follow this section. Now here's a question: how are ions held together in ionic bonding? Well, basically the oppositely charged ions are held together by strong forces of attraction. So that should be the answer, and I'll just check to make sure. It looks good. We'll just see here. It says, what section are we on? Yeah, C3.3. The oppositely charged ions are held together by strong forces of attraction. Yeah, that's what I just said. And then, by the way, if you can see, I got a pen. If you probably noticed that I got a pen here, so I'll be doing some work on paper, probably, most likely, in this video. It's a very short section, so probably I can explain a bit more today, hopefully. Atoms from group 1... so we've done that question. So now the next point is atoms from group 1 form 1 plus ions, and atoms in group 2 form 2 plus ions. Atoms from group 6 form 2 minus ions, and atoms from group 7 form 1 minus ions. So I need to explain that. Basically, group 1 elements have basically 1 electron in their outer shell, right? And basically they want to get rid of that, because we know that when atoms react, they form compounds, basically. atoms of different elements can react to form compounds. And basically the reason why they're reacting is so that they can have a full electronic configuration. The stable electronic configuration, like that's similar to that of a noble gas. So if for example group 1 has one electron, if there's an atom which is in group 1, obviously atom of an element in group 1, it's it'd want to lose that electron so that it can have a full 2 shells, basically, because otherwise what happens is or full 2 shells, basically to have full shells. I'm not sure if it's full 2 shells, it could probably be 3 shells, I'm not sure. Basically what I mean, don't forget about what I just said, I just mean because they have 1 electron in their outer shell, they want to get rid of that 1 electron so they can have full electron configuration. That's why they form 1 plus ions, because they lose that electron, so they have 1 more proton than electron in their in their structure, in their atoms, in the ions. And group 2 form 2 plus ions. So basically similar thing here. For group 2 elements, they have 2 electrons in their outer shell. They'd want to lose both of those 2 electrons so that they can they can form stable. They can have stable electronic structures. And if they lose those 2 electrons, they have 2 more protons than they do of electrons, and basically that means they form 2 plus ions. That's why it's called that. Now atoms from group 6 form 2 minus ions. Now to explain that, elements in group 6, we know that they have 6 electrons in their outer shell. So instead of losing all 6 of them, it's actually easier to gain 2 electrons, because obviously 2 is less than 6. So if they gain those 2 electrons, they would have 2 more electrons than they do protons, because obviously remember with all this we're saying we have neutral atoms, so the number of protons equals the number of electrons. So if you now add 2 more electrons, you're basically going to have, if you add 2 electrons, you're going to have 2 more electrons than protons. Sorry, so therefore you have a 2 minus charge. And the same thing goes with group 7. They have 7 electrons in their outer shell. So elements in group 7 have 7 electrons in their outer shell. It's easier for them to gain 1 electron than it is for them to lose 7. So that, because obviously they can have 8 maximum. So they gain that 1 electron. They'll have 1 more electron than they do protons, obviously. And so they form 1 minus ions. So hopefully that makes sense. And basically the same thing can apply to group 1. I didn't talk about this in that sense for group 1 and groups 2 as well. For group 1 and group 2. But basically what we have to say is group 1, they have 1 electron in their outer shell. It's easier for them to lose that electron than it is for them to gain 7 electrons. So they lose that electron, they have 1 more proton than they do electron. So therefore they have a 1 plus charge. Same with group 2. They have 2 electrons in their outer shell, elements in group 2, that is. So it's easier for them to lose those 2 electrons than it is for them to gain 6 electrons. So that's why they lose those 2 electrons. They have 2 more protons than they do electrons. The number of protons is basically 2 more than the number of electrons, and therefore they form 2 plus ions. And it's not in the book, but you just need to remember as well that group 3 form 3 plus ions and group 5 form 3 minus ions. So just remember that. You don't really need to know about group 4 much. Don't need to know about the kind of the charges they have and the ions they form. That's a bit more complicated. You don't need to know about that for GCSE. And the reasoning behind 3 plus and 3 minus for groups 3 and 5 respectively is basically the same reasoning for group 1, group 2, group 6 and group 7. So hopefully that makes sense. Now here's a diagram, and hopefully you can see that diagram, and I will explain it. So magnesium. Here you have kind of an ionic bonding shown between magnesium and oxygen. Now magnesium is in group 2. So you draw the electronic configuration for magnesium, for neutral magnesium, which as you can see, hopefully you can see it. It's quite hard to show here, but hopefully you can see it's 2, 8, 2. Yeah. And then an oxygen, it's 2, 6. Oxygen, hopefully you can see it's 2, 6 there. So what happens in ionic bonding? Because magnesium wants to lose 2 electrons, so that magnesium would rather lose 2 electrons than gain 6 electrons, and oxygen would rather oxygen would rather gain 2 electrons than lose 6 electrons because of the reasoning we've said before. Because they're in group 2 and group 6, they're in groups 2 and 6 respectively, they will ionically bond, and the magnesium will transfer 2 of its electrons to oxygen. So now you can see magnesium first originally had 3 shells, but now magnesium only has 2 shells because obviously it had 2 electrons in its outer shell, which it has lost. So it's completely, that third shell completely disappears. Hopefully that makes sense. And now oxygen now it's got the, and now by the way, magnesium now had the electronic configuration of 2,8 because it has lost those 2 electrons from the third shell. And magnesium and oxygen now, because it was 2,6 before, now it forms 2. Now it's 2,8. Hopefully you can see 2,8, and hopefully you can see that this is an X here, and there's an X here as well. You can see there are 2 X's. Amidst the dots as well, but there's 2 X's and they've come from the magnesium. So basically what you've effectively formed is from Mg2 plus and O2 minus, the charges balance out each other, they cancel out, and basically form MgO, which is known as magnesium oxide. So when magnesium oxide MgO is formed, the reacting magnesium atom loses 2 electrons and the oxygen atom gains 2 electrons. So hopefully that makes sense. And one thing I want to point out, which I don't think I'm probably going to draw the diagram because I did in the last video, hopefully that should have made it clear, even though I messed up a bit. This is Mg now 2 plus, hopefully you can see, and then this is O2 minus. Because there's obviously O2 minus, because obviously Mg2 plus because it's lost 2 of its electrons, so it's 2 more protons than it does electrons. And then O2 minus because it's obviously gained 2 electrons, so now it has 2 more electrons than it does protons. So 2 more electrons than protons, basically. So hopefully that makes sense. I think I explained it well, hopefully. So I'm not going to bother, drawing it out, drawing anything else out. All you need to show is basically transfer of electrons, and basically when you're doing it, just show an arrow here. Just use an arrow to show these are the atoms. You form the ions, and basically remember the metal atom loses the 2 electrons to form metal ion, which is positively charged, and the non-metal atom gains those electrons. Gains those electrons to form a negative ion, which is obviously an anion, and the positive ion is known as the cation. So now here's a question number 2. Calcium is in group 2. What is the symbol for a calcium ion? Well, because it has 2 electrons in the outer shell for calcium, because it's in group 2. We've gone through this before. It will lose those 2 electrons in ionic bonding, and it will basically form Ca2 plus. So the ion formed would be Ca2 plus. So that should be the answer. Ca2 plus should be the answer. Yes, it is. Just make sure, yes it is, because the 2 plus is very small. Right, on the up, you should basically be able to, that's what it says here, on the up, be able to draw dot and cross diagrams of unfamiliar ionic compounds. Right. One point I want to make here is, now we've obviously seen, ionic bonding with compounds that have 2 plus and 2 minus, or 1 plus and 1 minus, so that's easy. What about if we had to do something between calcium and chlorine? So what you do here, so I'll actually draw it first. I might draw this actually, just to explain it. Calcium has, wait 1 minute, calcium, because we were just going through calcium, so I just want to kind of see the atomic number and stuff for calcium so that I can, 1 minute, calcium, sorry if my face goes in the middle, but 20, 1 minute. I want to just show something very, very important. Here. Also, I'm going to show you my diagram. It's going to look a bit horrendous because I'm doing quite quickly, but you should draw your electronic configurations with, take some time drawing them because they are very important in chemistry. It takes so long to draw calcium. It's got 20 electrons. This takes, oh my god, it's so long. Basically, wait 1 minute, calcium. Here we go. And then we do the same for chlorine. And one thing I forgot to mention was, because it's dot and cross diagrams, you can put the dots on any of them, dots and crosses on any of the two elements, basically. Just remember, one is dots, one you have to put dots on, one you have to put crosses on, the other you have to put crosses on, but it doesn't matter otherwise. Now, wait, have I done everything? 1 minute. No, wait. 2, 4, wait, 1 minute. No, wait, this should not be there. This is not there. But basically, right, this is calcium. This is chlorine. Ignore that big squibble there. You can see that blue one. That's not meant to be an electron there. I did a little mistake there. But now what I'm going to do is look. Now look what I'm going to do. Is I'm basically going to have 1 minute. 1 minute. So now calcium forms 2+, but chlorine can only gain 1 electron. That's why you've got to have 2 chlorines there. Hopefully you can see calcium 2+, and Cl 2Cl-. So what that would effectively form is CaCl2. Because basically what I'm trying to show is the same process of what we've done before. But you draw the 2 atoms that you have, and then you draw the ions, showing the transfer of electrons. But basically, and I think instead of saying 2Cl-, I think it's going to be better to actually draw out both, Cl- and then another Cl- below that with square brackets, not the way I did it. But that was just to show you. Because obviously chlorine can only gain 1 electron, because it only needs 1 electron to fill its outer shell. But calcium needs to lose 2 to basically have a complete stable electronic configuration. So that's why there's got to be another chlorine that can take its remaining electron that calcium still needs to lose. So you'd have 2 chlorines and you'd have 1 calcium, so you'd have CaCl2. So Ca2+, and then Cl-, is basically 2Cl-, so Ca2+, and 2Cl- just gives you CaCl2, because you now have 2 atoms of chlorine for 1 atom of calcium. So hopefully that makes sense, and hopefully you got a much better understanding of ionic bonding today after today's session, section, video. Yeah, keywords. Here are giant structure and giant lattice, and just to finish off, let's go through the key points. Ionic compounds are held together by strong forces of attraction between the oppositely charged ions. This is called ionic bonding. Now, besides the elements in group 1 and group 7, other elements can form ionic compounds, including group 2, which can form 2+ ions, and group 6, which can form 2- ions. So the thing with this revision guide, it only showed group 2 and group 6, but basically you could also be given a group 3 element and a group 5 element, and the principle is the same. Group 3 wants to lose its 3 electrons, an element in group 3 wants to lose its 3 electrons, and then an element in group 5 would want to gain those 3 electrons, and therefore then basically you'd form 3+ and 3-, which would basically cancel out, and then you'd form your compound. But also I've shown you that it doesn't have to be equal charges, equal charges in magnitude. It does magnitude as well. It doesn't have to be 3 and 3. It could be, for example, like I've showed you, 1 and 2. So in that case, you need to double the element that has the lower charge. And you could have You know, you could have had something like 1 and 3 as well. You could have an element in group 1 with an element in... you could have an element in group 1 with an element in group 5. You could have 1 plus and 3 minus. In that case, you'd have to triple the group 1, basically, the number of atoms of group 1 you have. So hopefully that all makes sense. That's the end of the section, guys. Really hope you found it helpful. I will put the links to both C3.2 and C3.3 hopefully soon by today, and make sure to share, like, and subscribe. Turn the notifications on if you haven't already, so that you're notified and updated when I upload new videos, that you can watch. And tomorrow's section is C3.4 giant ionic structures. And basically, just before I finish off as well, I want to just say that in exams they're mostly going to tell you to draw the outer electrons, not the whole electronic configuration. Because you can see calcium, it takes so long to actually draw all the electrons out, and even for chlorine. So they normally just tell you to draw the outer electrons, and you should know how to do that quite easily. It's just how many electrons it has in its outer shell, and then use the transferring of electrons and ionic bonding. But basically, I'm going to wrap up here. I think that's I'm going to stop here. See you in the next video for C3.4, which is going to be about giant ionic structures. So still linked with ionic bonding. So yeah, I think I'll go now, guys. Thank you very much.